Alright, welcome to another AQA A-level chemistry video. I'm trying to do something a bit different today. So, I'll just be going through the basics of chromatography. Now, there's one more topic left, one more big topic within organic chemistry, and that's NMR. But the two topics that's related to identification for year 2 organic chemistry are chromatography and NMR. And as well as, so in total of all of them, you have infrared. So you have your chemical tests. So the ones with the halide ions regarding ammonia and silver nitrate, and then you've got to test physical tests in terms of chromatography, NMR, and IR spectra. So I'll be going through I've already gone through one of them in terms of IR spectra. Have I gone through IR spectra? I should have went through IR spectra. I would have definitely gone through IR spectra. I mean, okay, if I haven't gone through that, then I'll make a video on that in case I haven't. But I'm pretty sure I have done a video on that. I'm not gonna go put that in the link in the description because I'm too lazy to do that. But the chromatography is a topic that you guys need to know, because how they do it in the exam is that I've just talked about all the different ways that they can put all the different methods of identification. And sometimes they don't like just to talk about, they won't just talk about just chromatography, or they won't just talk about just NMR. They'll get, like, say, question 13, for example, which is out random. They'll have a mix between, here is a chemical and it has this in its, and they'll show you like it's graph on chromatography, and then they want you to explain the diagram with different compounds in it. Maybe they want you to work out the RF values, and then the part B and C of that question, they'll say it's this compound here. So what if it's an alcohol, what would you expect its IR spectra to be? So just be wary in your exam. And even after that, they might say you have now it's this compound here, this compound here, this compound here. It's going to be in that. Here's the or they might say the part C to that question might just be, here's now an example of an NMR spectra, H1 NMR spectra. Now you know that what type of compounds this is. Can you draw could you draw out? So now that you know what's in the compound, can you now draw what the compound is? Now, I'm not going to go through NMR in this video. I'll go through NMR next. But just to give you a heads up, when you're going through identification, it's not just going to be just chromatography. It won't just be just NMR. It won't just be just IR spectra. They like to mix and match and chop and put different parts in. So it's good idea. It's very good. They're testing your understanding of the topic and how, because in reality, in science, I know I'm waffling on a bit here, but I'm trying to explain to you why they do that. Because in science, you're not just going to rely on one form of identification. You may rely on chromatography and NMR, or NMR and IR spectra, to give you a good idea of what compounds you have when you're doing identification. And that's what they're testing you here. Do you understand chromatography enough to understand that, how it works, what it represents, and can you now relate it to other forms of identification? So I don't want to talk too much now. I'm going to go straight into the video, but I'm going to go through the basics of chromatography. And yeah, that's it. I promise I'm going to go through it right now. All right. So chromatography is a common separation and products identification technique used by chemists. So the basics of chromatography. So chromatography works to separate substances based on their interactions with a mobile and stationary phase. The mobile phase is typically a solvent, and the stationary phase is typically a solid support. So if you've done chromatography from GCSE, you'd know that basic understanding of chromatography that you'd have. And chromatography is mostly, well, it's some the aspects of chromatography you should understand from GCSE, but there's different types of chromatography. So there's normal chromatography that you know of, which is with the paper chromatography. But there's other ones we have thin layer chromatography, which is similar a bit to the normal chromatography they're used to, but it uses a different type of stationary phase. But there's column chromatography, there's gas chromatography, there's different types of chromatography, but the basic idea is that they all have a mobile phase, which is typically a solvent, but it doesn't have to be, and a stationary phase, which is typically a solid support of some sort. And they do follow this idea of the each compound can be identified by its ability to have a certain affinity to the stationary and the mobile phase, and based on and each compound has, so each compound has its own affinity to the stationary and mobile phase, and based on that, it will place itself in a specific position, uh, in the chromatogram. In the chromatogram, it will place itself in a specific position because of a specific affinity to either the mobile phase or the stationary phase. If it has a stronger if it has a stronger affinity to the mobile phase, it'll move up more up. For example, if you're talking about the paper chromatography that you're used to in GCSE, if it has a stronger affinity to the mobile phase compared to the stationary phase, it'll move higher up the chromatogram compared to a compound has a stronger affinity to the stationary phase, i.e., it won't move that far up the chromatogram because it has stronger affinity to the stationary phase, the solid support, rather than the mobile phase. I would kind of go deep into why that is and why that's the case, but I'm just going to continue on with the rest of this topic. So, the process of chromatography. So, a substance is allowed to interact with both the mobile and stationary phase in either a column or a plate. The more a substance interacts with the stationary phase, the longer it would take to reach the bottom of the column or plate. And we say it takes longer to elute. So when you're talking about elutions, this relates more to column chromatography, which is where you have a column and you're seeing how long it takes. You have some sort of solid support, which is like the walls of the container, or be a stem in the middle, and that acts as the stationary phase, and the mobile phase obviously be the solvent, and you're seeing how long it takes for our sample to reach the bottom. So we have a sample here, where I use this color. So this is our sample here. Solvent, stationary phase, and we're seeing how long it takes for each, because basically this is a mixture here, right? This right here is a mixture. That there is a mixture, and it has multiple different compounds within that mixture, and it gets separated. I'll go through it when I go fully deep into column chromatography, but the solvent allows the different compounds in that mixture to get separated, and over time, the ones that have a stronger affinity to the mobile phase will move more quickly down the column by gravity, because they have a weaker attraction, they have a weaker affinity to the stationary phase, so they're less likely to get attached to the stationary phase. Yeah. So as I said before, now I finally I was conflicted about what I wanted to say, but I just reevaluated it. It was correct. What I was about to say. What I was about to say is that more polar compounds tend to be more attracted to the stationary phase than the mobile phase. So less polar compounds are attracted more to the mobile phase compared to the stationary phase. So hopefully that just made sense. Hopefully that made sense what I was trying to say there. So the more polar a compound is, typically it means it's more strongly it has a stronger affinity for the stationary phase, and vice versa. So a less polar compound would have a higher affinity for the mobile phase. Hence, that's why more polar compounds, if you're talking about paper chromatography, they would move less up the chromatogram because they have a stronger affinity to the stationary phase, so they wouldn't move up and have a lower affinity to the mobile phase, and hence wouldn't move that far up. And when it comes down to column chromatography, we talk about the time for elution, the elution time, and they would elute less quickly because they have a stronger affinity to the stationary phase, so they'd get more. They would take they're more strongly attracted they have a they have a higher affinity for the stationary phase compared to the mobile phase, so they'll move less slowly because they're more strongly attracted to the stationary phase, and they'll have a longer time of elution. Now you see that here. So from this example that I can see here, we have a red compound. The red compound here is more. I can tell that's probably less polar because it has a faster elution time. See, it reaches the bottom first, so it has a higher. So it has a smaller elution time, which means that it elutes faster, which means that it has a weaker affinity to the stationary phase, and a higher affinity for the mobile phase. So that's one thing I could understand from this compound here, and the blue compound here, higher affinity for the stationary phase, and so hence higher attraction to the stationary phase. It elutes less quickly, and reaches the bottom less. And we time this here. We say this takes maybe 3 minutes, and that takes maybe 9 minutes, for example. I'm just saying for example, but yes, there's different types of chromatography. I'll get into more detail about column chromatography, but this is just kind of introducing you to chromatography, and certain aspects of it. So it's important to know the process of chromatography. Also important to use the word affinity. You can get away with this with a strong attraction. You can get away with in your exam. You can get away with the word strong attraction, but you always get the mark just for saying affinity. It just shows the examiner that you know what you're talking about. And yeah. Separation or identification. So, chromatography can use different elution times of different substances, and separate substances they leave the column or plate at different times. So we can use so different compounds. As I said before, different compounds will have different elution times, and you can identify substances using RF values. And you should be aware of what RF values are for paper chromatography. Now, the only RF value the only RF value you should know is the one with paper chromatography, and that's the only one you have to calculate in your exam. It's a very easy thing to calculate. Am I gonna put it down here? You know what? I mean, actually, you know what? In the next video that I do, I'll be talking about how to work out RF values. But you should know RF values already. So it's just the distance. It's just the distance traveled by the substance over the distance traveled by the solvent. Sorry, I'm kind of stuttering a little bit. I've got retainers in my mouth, so it's a bit hard for me to speak. But it's the RF value is just the distance traveled by the substance over the distance traveled by the solvent, or solvent head. But yeah, it's important to just know that it's about that you can use it to identify. You can use it to separate, or you can use it to identify what type of compound you have, because specific compounds have specific RF values. Now, the last one is retention time. So in gas chromatography, we typically measure the time taken for the substance to elute from the column, and this is called the retention time. So substances with a large retention time interact strongly with the stationary phase. As I said before, so gas chromatography in the way you so retention time, elution time, is typically called retention time. Even with the column chromatography, it's called retention time, but it follows the same principles in terms of the way it's measured with column chromatography. So gas and column chromatography have some similarities in the sense that so specific compounds will have a specific elution time with a specific solvent. So if you have, for example, let's say you had a solution of ethanol, right? And you wanted to know what the retention time of ethanol is. For different substances, it may be different. It may have a different, with different solvents. When you're working out the retention time, it may be different. But there is a data booklet that tells you about the retention time for a specific compound under a specific solvent. That's the way of identifying it. So that if you have a specific solvent that you're using and you want to work out the retention time, so if you have a specific compound that you want to work out and you have a specific solvent and you want to work out the retention time, you can go into a booklet and see how long it would take and compare it to the ones that you got when you did your experiment, and say, do they match? Yes, they do match, roughly match. So I'm confident that this compound that I have here is ethanol, for example. But substances with a large retention time interact strongly with the stationary phase, as I said before, and substances with a small retention time interact weakly with the stationary phase. All right, so I'm just gonna go and get to the end of this now. So, because I know I've kind of maybe waffled a little bit too much on this topic. It's the first time me trying to do a video this way, so bear with me. If by the way, at the end of this video, kind of like if you like the way I've done this video, somebody kind of suggested it to me, and I thought maybe it might be better this way, because sometimes the camera kind of shines and reflects off the reflection of my iPad, so it kind of makes it harder for you to see what I'm writing down, or and if I have an image that you see. So if you prefer this way, or if you want me to go back, I will do the other way as well. But if you prefer this way, just let me know, and leave a comment, as well as like and subscribe to this video if you like this type of content, of course. If you don't, leave a comment and I'll try and improve these videos. Always leave your suggestions. I will always appreciate any questions or any comments you think could help me, and be honest. Anyway, so chromatography. What have I got to say about this to summarize chromatography? So you got the mobile phase. I'm not going to say too much really. Mobile phase, typically a solvent. This is the most important part. Just understanding you have a mobile phase, which is typically a solvent, a stationary phase, which is typically the solid support, and what connects the two, that for identification, really is affinity. You think I'd say retention time, RF, really the thing that links the two for identification, because at the end of the day, also chromatography is to identify a compound. The thing that actually links the two for identification is affinity. Affinity to either stage. And that's what helps you understand if it has a strong affinity to mobile phase, that will help you give a specific RF or elution time because it will move more quickly. If it's if it's moving, it may move more quickly or may move further along because there's stronger affinity for the mobile phase compared to the stationary phase, or vice versa. But the thing that actually links it together to allow you to identify is affinity. So yeah, that's the end of the video. Hopefully the video was helpful and hopefully found it actually useful. If you have anything that could probably help me, if you like the way I did this video, yeah, like the video and give me your thoughts.